Okay, so let's start the class. In the last class, we are discussing about the NumPy concept and array concept. So in this particular class, we're going to understand about the how to create the array, how to work with the array. Okay, so let's go with the one dimension array. So how to create the one dimension array? So first of all, you have to import the NumPy library as a NP, and here you have to take one particular variable. Let's take a1 equals to something, and here I'm going to use the array, and here simply you just need to mention the some particular 10, 20, 30, and 40 units. Okay, and once I save this, and if I print this a1, I can see perfectly printing. And if I write here type of the a1, okay, it is numpy n dimension array. Okay, and how to check any particular array's dimension here? So simply you can write a1 dot n dimension. Okay, so here you're getting the one here, so it means it is a one dimension array. So simply you just need to mention the np dot array. In the last class also we have learned the all the declaration, defining, and accessing area. So same thing here, just you need to import the library. Once you import the library, you can mention the reference variable name. If you're not mentioning any reference variable, directly you have to mention the numpy. And then array function, and for the one dimension, you just need to mention the only one square bracket. Okay. And if I wanted to access any particular value, you have to mention the index number. So directly you can mention the index number, a1 of any particular value. So now you can see here 10 is printing. Same thing, a1 of 1, okay, 20 is printing. Okay. Now if I wanted to store the two dimension, so let's take one particular variable, and here I'm going to use the np dot array. And in the particular two dimension, first you have to create the main structure. Inside of the main structure, you have to create the row, and inside of this particular row you have to add the column values. So let's store some particular 10, 20, and 30, 40. Let's create one more row, and here I'm going to store some more particular values here. Okay, let's take one more particular row, and here I'm going to store some more particular values. So now you can see here, this is my first row, this is my second row, and this is my row number 3. Okay, and once I run this, the values are printing perfectly. And same thing, if I wanted to check what is the dimension, so you can use the n dimension command. So you can see here is a 2 dimension. And if I wanted to check how many rows and column values are there, so simply I can use the shape command. So using the shape command, you can see 3 comma 4. 3 comma 4 means here first defined the first value goes for the rows, second value is defining for the column here. So first here the saying row, and next is the column. Similarly, if I wanted to check how many values are saved inside of my array, you can use the size command. So here you can see 12. So now you can see here 4 plus 4, 8. 8 plus 4 is 2. Next thing, if I wanted to access any particular value from this A2, so here I need to mention the first row index, and then I need to mention the column index. So let's take an example here. I wanted to print 44. Okay. So now 44 means this is the zero index. This is the first index. So here you have to use the first. In the first index, this is zero index, first index, second index, and third index. So here I need to mention third. So now 44 is print. Similarly, I wanted to print, okay, 3. I can see 3 here. So it means it is a zero index, first index, and second index. So here I need to mention A2 of second index row, and then column. Column means this is a zero index column. So here I need to mention the zero index. In this way, you can access the any two dimension, any particular two dimension array, particular data. Clear? Any doubt, any questions? Let's go with the next one, how to store the and access the three-dimension data. For three-dimension data, let's take one particular variable name here. Same thing in p.array. And here, first of all, I need to use the main square bracket. In the main square bracket, we have to mention first particular block. So this will be your first block. And inside of the first block, you have to create the row. So this will be your first block. Okay. Like this. After that, you can create the second block like this. So you can create n number of particular blocks. Now inside of the block, again you are creating the first row. You can store some particular values. Let's store some values 3 comma 4 comma 5 comma 6. Let's store some more values 20, 30 and 40. 7, 8, 9. Okay, and let's store some more particular values here. Okay, like this you can create n number of particular blocks. There will be no restrictions will be there. So this is my main particular block. In the main block there is a first block is there, and this is the second block is there. And each and every block contains some particular rows, and each and every row contains some particular column values. Now I wanted to check whether it is stored or not. You can run the A3. Now you can see the structure is stored here, and if I wanted to check what is the dimension here, you can check the dimension is a three-dimension structure. And after that, if I wanted to create uh, what would be the shape of this matrix. So you can see here 2 comma 3 comma 4 means two blocks are there. So first blocks, next is the rows, and next is the columns. Okay, so first two blocks are there, and each and every block contains three rows, and each and every row contains four columns here. Okay, so this is a way like how you're going to check any particular matrix. Okay, shape. Next is size. How many values are saved? You can using the size command, you can check it how many values are saved here. Similarly, if I wanted to check any particular value, if I wanted to access any particular value, let's take something. I wanted to access 2 here. So you can see here 2 is here available. So this is my first. I need to mention the block index, then row index, and then column index. Block means this is the zero index block, and 2 is available in the 0, 1 second row index, and column is nothing but 0, 1, 2 and 3. Okay, so this will be your 0 index block. In the 0 index, this is the 0 index row, this is the first index row and second index row. In the second index row, again 0 index value, first index value, second index value and third index value. Like this you can see 2 is. Let's assume I wanted to print something 11 I want. Okay, so here we need to mention same first block, so it is available in the first index block, and then I need to mention row, again it is in the first index row, and then column value, it is a zero index column value. Okay, so this is the way how you're going to store and access the three-dimension data. Apart from that, you can create some particular built-in array also, like fixed arrays. There are different arrays are there, fixed arrays. Let's see, built-in or fixed arrays. These type of arrays also you can create using the ready-made functionalities. Example, I want all the values as a zeros. So there is a array called, there is array function called empty function. So using the empty function, you can create all the values as a zero. So let's create a equals to, and here I need to mention the empty function. And inside of the function, I need to mention what particular shape I need to mention. Let's assume two rows and three columns I want. So now you can see here one particular empty values are saved here. You can see there is some random values are saved in the some floating format. Okay, but here you can see one value is coming. It should get zero value. So why zero is not printing? It should print zero. Stay. Okay. So here I need to give the equal particular dimensions. You can use the zero particular function also. Zeros. And here also you can give any other particular dimensions. Now you can see here zero is printing. For empty, I need to give the equal rows and columns here. And for zeros, you can give the any particular dimensions. Okay, let me change the any other particular dimensions. Something 5 comma 3. Okay, so you can see all the zeros are. If you don't want the decimal values, you can remove the decimal values also using the data type. One more particular argument you can pass you can pass data type equals to integer. So then it is going to be converted as an integer value. Similarly, there is a one function is there, like all the values are going to be placed as a one. So here a equals to np dot one. Here I need to pass the dimension. Let's assume 2 comma 4. And now you can see all the values are printing as a 1. But there is a no 2 3 function are there. After that you need to mention the full function. So here I just need to mention a equals to np dot full function. And here I need to mention what dimension you required. For example, I need 2 comma 3 matrix, and the value I want something 8. Okay, and now you can see here all the values are become 8 here. Similarly, you can mention any matrices. For example, 4 comma 3 matrix, all the values I want as a 7. So now you can see all the values are printing 7 here. Apart from that, there is a I matrix will be there, where all the middle values are come as a 1. So you can use np dot I matrix. And here I need to mention the dimension, uh, something 3 comma 3. Okay, I think error is coming. Okay, I need to mention only like how many ones are required. So now you can see 3 ones are required. So here you can see 3 ones are coming. Similarly, if I increase the values, automatically the rows and columns are going to be increased, because in the I matrix there will be in the middle all ones will be there. If I mention 5, so now you can see here 5 ones will become in the middle part. Remaining all the values are 0 only. So this is your I matrix. But instead of 1 in the middle, if I want some other particular values, that is called diagonal matrix. So if I wanted to create any diagonal matrix, so you can create A equals to np dot diagonal matrix. And here I need to mention which numbers you wanted to print. For example, I wanted to print 5 comma 7 comma 9. Okay, and once I run this, now you can see here in the place of 1 you're getting the 5 7 and 9. Clear? Any doubt, any questions? We have one more particular function is there, array range function. So if I wanted to store any particular range of values using the array, so you can go with the range function here and you can create any particular range of values array, like how we have already used the range function in the loop. So same thing you can do, you can create any variable and you can mention instead of normal range, you can mention array range, a range. And you mentioned some particular values. So now you can see here, these values are 4 means 1 to 3, 3 values including 0. fourth value. And once you mention these particular values, for example, you can change starting number as a 1, ending number as 11, so that values are going to change. You can use with the difference point also. For example, I'll write difference point, so now you can see here difference odd values are printed. Okay, so this is the way like how you're going to store this particular different range of values. You can increase the range, you can decrease the range also. uh, let's add one more. So here I wanted to start with the 2, end with 26, difference of 2, and now you can see these values are saved. Okay, and you can use the length function also to check how many values are saved. So total 12 values are saved here. Now you can convert also one dimension to two dimension, two dimension to three dimension. Like this also you can do. Okay, so now let me convert first to one dimension. So one dimension to two dimension. So 12 I can convert 6 into 2 also, 4 into 3 also, 2 into 6 also, 3 into 4 also. Different formats we can convert. Okay, so let's take one more variable, something b1 equals to a reshape function, from which variable I'm going to convert from a, and what is the uh, shape you wanted to convert. So I want, just assume 4 comma 3. So 4 rows, 3 columns are required. Okay, reshape. Okay, here I need to mention the numpy function. Okay, and once I run this, now you can see here 4 comma 3, it is going to be convertible. Similarly, if I wanted to convert one dimension to three dimension, so total 12 values are there, and if I wanted to convert this 12 values, means I can mention 2 into 3 6, 6 into 2 12, or else, or how I can convert 2 into 2 4, 4 into 3 12. In this particular manner also you can convert, right? So let's go with any particular. So here I'm going to take one more variable as a c1, and here I'm going to mention np. So np dot reshape, and here I need to mention from which variable I'm going to convert from a variable, and what is the shape I wanted to convert. So here I'm going to mention 2 comma 2 comma 3, means two blocks will be there, two rows will be there, and each and every row having the three particular column values. And once I print this c1, so now you can see here it is converted. Similarly, you can convert two dimension to one dimension also. Okay, we have just now we have converted b1, right? This is a two-dimensional structure. And now what I wanted to do, I wanted to convert this into the one dimension. So same thing you have to do, you have to create one particular variable. Let's take a2, and in the a2 I need to mention np dot reshape, and here I just need to mention it which variable. So from b1, and what is the shape here? Shape is only one value, so 12 will be there. So here you can see it is converted as a, all the particular 12 values will be considered as a one particular dimension. Similarly, I wanted to convert two dimension to three dimension. Okay, so let's go with the same thing. Let's create one more variable, something c2 equals to np dot reshape. Same 12 values are there, from which variable, from v1, and which dimension you wanted to convert. So let's go with the 2 comma 3 comma 2. 2 into 3 6, 6 into 2 12. Okay, so now you can see in this particular concept you can easily convert two dimension to one dimension also, two dimension to three dimension. Let's go with the conversion of three dimension to one dimension. Same concept will be there, only variable name is changing, remaining will be same. So here I'm going to create one more variable as a a3, and here I need to mention np dot reshape, and here I need to mention from which variable I'm converting. From c2 I'm converting, from c2. Okay, how many values are there? 12 values, that's it. Okay, now you can see it is convertible. Similarly, I wanted to convert 3 dimension to 2 dimension. Now, same thing here I need to do. I need to just create one particular variable. Let's take B2. And here I'm mentioning here np dot reshape. And here I need to mention from which variable, from, okay, this 3 dimension name C2. Okay. And what is the matrix I wanted to convert? Let's take 6 comma 2. Okay. And once I run this, now you can see here all the values are printing perfect. Is it clear? Any doubt, any questions?
No, sir.
Okay. Next thing is, okay, how to convert the transpose matrix. Transpose matrix means it is going to be reverse the matrix shape here. Means transpose. For example, there is a x comma y. Okay, this is a one particular matrix format is there, shape is there. So it is going to be reverse. It will become y comma x. For example, there is a one array is there in the form of something 2 comma 3. So now what will happen? It is going to be converted as a 3 comma, like this. Okay. So here let's convert this particular B2 as a transport matrix. So we have already one ready-made function is there, and the function name is called transpose. Okay, so just you need to create one variable name. Let's create one variable name as a B3, and here I need to mention transpose, and from which variable I wanted to convert from the B2. Okay, so now you can see here it is converted as a 2 comma 6. If I wanted to check B3 dot shape, okay, I'll just type print. Same thing, I'm going to write the B2. Okay, what is shape function is not a function, it is just a command. So now you can see earlier it was 2 comma 6. Okay, sorry, 6 comma 2. Now it is 2 comma 6. So this is called transpose. Means just we are going to convert the same particular shapes here. Okay. Now you can do some mathematical functions also. Uh, like there is a two particular we have already using in the last class plus symbol, but apart from the plus symbol, uh, there is the addition, subtractions, all these particular functions are there. If I just write here numpy mathematical, mathematical functions. Okay, so this is the official website. So now you can see there are different functions are there: trigonometry, round, sum. Okay, I'll go with this sum function. Oh, any basic functions are there, arithmetic operators. Okay, you can see here add, multiply, divide, power of the value, subtractions. Okay, so let's go with some basic particular functionalities. Mathematical. Okay, so let's store some two particular array. Let's give array one equals to something and p dot array. Let's store some values 1, 2, 3, 4. Let's store array 2, and here I wanted to store 5, 6, 7, 8. Okay, so now I wanted to perform the addition here. So simply you can create one result variable np dot add function and array 1, array 2. Okay, and once I print the result, now you can see here 1 plus 5 becomes 6, 2 plus 6, 8, 3, 7, 10, 4, 8, 12. Okay, similarly you can print the subtraction. Okay, so the spelling subtraction. add, okay, this is for me. Let me just type it here. Subtract. Okay. So now you can see here 5 minus 1, like this it is printing. So if I just give the values first 2 and then 1, now it will print in the positive. Okay. Yes. 5 minus 1, 6 minus 2, 7 minus 3, and 8 minus 4. Like this, we have multiplication function. Okay. There is always some function also there, right? Let's apply that sum function also. We have the sum of the array. Okay. So now you can see here, this is the array 1, 1 plus 2 plus 3 plus 4, nothing but the 10. Okay. So this is the way like you can use some mathematical functions. Apart from that, you can use some statistical function also. If you just write here statistic. Okay. You can see here mean, median, standard deviations. Okay, all these things you can get here, correlated values. Okay, so different things are there. Let's go with the mean, median, these functions. So here I'm going to create same thing, result. Here I'm going to write mean of the given particular array. Okay, so you can see mean. Similarly, median. Okay, so there is an average also there, right? So average spelling. Okay, so full name is there. Okay, so in this way, you can, if we have the standard deviation also, steady. Okay, like this, there are different type of statistical function also you can create. Okay, apart from that, you can add in, you can append any particular values also. Okay, uh, so if there is a, let's go with the two dimension adding a row. Okay, and then we'll go add a column also. So simply there is a one row function is there. Okay, if I just write here numpy r function. Okay, so you can see here if I wanted to create, okay, adding the, okay, there is a append function also there, and row function also. There are two functions are there. You can go with any particular function. Okay, let's go with the, okay, here they have mentioned the column, but I wanted to go with the row here. See, column. Okay, maybe some other documentation. Okay, now you can see here there are R function is there, like which array I wanted to add here. Still example is not given properly. Okay, let's try. Okay, let's try here. So here I'm going to create same result variable, and here I'm going to use a numpy dot r function. Okay, and this function is going to be used to store the array here. So here I'm going to use the r, and which array I wanted to add. So let's we have v1. Let's take a small v2. Okay, let's go with this. So there already we need to add only two particular values here. Okay, so we just need to add two values. So simply what values we need to add, let's take something like v3 as a one variable, and here I wanted to store np dot array. Okay, and here I wanted to store the value here, like which value I wanted to add. So here I'm going to mention two particular values here. Let's take something values as a 26 and 28, two values I wanted to add. So v3 should be added inside of the v2. Now here I'm going to mention the r function, and now here from which particular variable, okay, I wanted to add. So in the v2 I wanted to extend this particular value. Which value I wanted to extend? I wanted to extend the v3, and I wanted to create a one more new array, or else you can save into the same particular also. Okay, both the things you can do. Now you can see here 26 and 28 is added here. Similarly, you can add the column also using the append function. So append function means we are adding the extra column values. So here adding extra columns in two dimensions. Okay, and same thing. Let's take v4. V4 is not available. v1, v2. Somewhere we have created v3. Okay, let's load v3 once again. Okay, now here what I wanted to do, I wanted to add the some particular extra column values. Okay, here also I want one column, here also I wanted to add one column. Let's store some particular values in numpy dot array. So here I wanted to add two particular values here. Okay, and these two values you have to add individually because these are the individual values. So let's store something 26 and 28. Okay, this individual two values I wanted to add. So same thing, let's take result equals to numpy dot append, and from which variable you're storing from v3, and what you wanted to add, I wanted to add v4. Okay, so simple command is there, and then I need to mention the access also, and here into mention access equals to, so vertically I wanted to add, that's why I'm mentioning one here. Okay, once it is added I wanted to print the result also. Now you can see here 26 and 28 is added. So this is the way you can use some particular built-in functionalities. Okay, there are different functionalities are there. Okay, let me give you assign you some particular task related to the array. Okay, the first question is write a program to store the odd numbers in between the range of 1 to 20 using the one dimension array, and then convert the one dimension to two dimension. Okay, and write a program to multiply any two dimension array. So transpose we have already done, so I'm going to change this. Mm, this extend to 60. So here whatever the result you have get in the 62 multiplication of two dimension, convert this as a transpose, or else just practice with any, okay, with two dimension, or else let's go with the three dimension. Okay, next question, write a program to store the array using the input function and print sum and average without using the ready-made function. Okay, So extra two we have already done with the two dimension. So here I'm going to add a program to add extra. Okay, add add data in one dimension. Okay, and to remove the data in one dimension. Okay, or else in the instead of transpose, here write a program to add a data in a specific index in one dimension. Okay, so adding a data. Okay, one dimension. By default, it will be in the last. It will be specific and it will be removed. Okay. Next question, write a program to find the maximum element of the given array without using the ready-made function. Minimum value same without using the ready-made function. And interchange. Interchanging means swapping the value. Okay, interchange means swap the value. So largest value should be swapped to smallest, smallest should be swapped to the largest. Means 10, 20, 30, 40 is there. So 40 is the highest, 10 is the smallest. So 40 should be changed the position to 10 and 10 should move to the 40. Okay. Next, write a program to store range of values in between 11 to 20 and then store the even numbers in between the 1 to 20. So simple programs are there. Just try to practice these things. Okay. And in the next class, we are going to understand one more particular uh, module concepts, one more particular library called pandas in the next class. Okay. Any doubt, any questions?